All right, hello Advanced Materials Show. Ready for the afternoon sessions? I'm David Jones, and this is Kyle Kopenhofer. We're going to tag team you today and give you the latest innovation in multiphysics computer simulation. We're with Altasim Technologies. Welcome to Columbus. It's actually where we're based. We're based outside of Columbus, so welcome here to the Advanced Materials Show. And what we're going to talk about today is using multiphysics computer simulation to really speed up your new product design. And with comes speed, come cost savings. And so you're going to learn about advancements today in computer simulation. Altasim has been doing this for over 20 years. So we're computer simulation experts. We can help companies, universities, help national labs work on engineering problems. And these engineering problems can be around product design or manufacturing issues. And what we do is we're a consultant. We go in and help you use computer simulation to get its full benefit. We get involved in consulting. We'll actually build your computer model for you so that you know it's correct and you'll get the best data out. We can help you with simulation apps. We can also do training and coaching. Since we've been doing this for a long time, we actually have a suite of educational materials that we can help you with. If you go on our website, we have free tips and tricks. We have webinars that we do. We have training sessions you can take, and you can also do one-on-one coaching sessions. Now, when we talk about multiphysics simulation, what we're talking about is a very high level of computer simulation where we're taking into account everything that's happening to your advanced material. So if your advanced material, for instance, is in a medical device and that medical device has to be implemented into the body, there's a lot of things going on there. There could be electromagnetic issues, there could be fluid flow, there could be heat transfer. And all of these things we have to account for so that we can give you a full, really, independence between these multiple forces. And what we want to do is really understand the real-world physical interactions that are happening so that those products will happen in real life, right? We're always about trying to get real-life data so that you can replicate those on your computer. And then we're all about accuracy. How can we provide the accuracy that you need so that your product is going to perform in use? The other advantage of multiphysics simulation is really providing a reliable design at a lower cost than prototyping. So think about how many times you can fail, how many times you can try things on the computer, and it doesn't cost you nearly as much as prototyping. Some of our customers say they save up to 50% of the cost of bringing a new product to market. That also results in accurate predictions. As you as a product designer or an engineer, you really want to know what the product's going to do. How are you going to predict what happens to that component or maybe that machine behavior? And you can do that through computer simulations. And really, it gives you the ability to deliver products faster at a lower cost. And with that, I'm going to turn it over to Kyle.
Good afternoon. Over the last 20 years, Altasim has conducted over 800 projects, and I wanted to talk with you guys about two of those projects. I'm going to keep it fairly high level. The reason I picked these two particular projects is because they're more associated with material processing. And so let's talk about the first case study. First case study was a condition where our customer had a composite material that they needed to dehydrate as part of their manufacturing process. And within this, this material had a chemical reaction that was going on. The byproduct of that chemical reaction, or one of them, was water. Once that chemical reaction had been completed, then the customer needed to remove the excess water from the material. They decided to heat that material, turn the water into water vapor, let the water vapor transmit through the porous material and out into the environment. The challenge was that if they evaporated the water too quickly, the water vapor would build pressure within the material, and then even to the point where that material would explode. So that was something that they were really trying to avoid. Now, this customer had an internal computational simulation team. However, this multiphysics problem was beyond the scope of what they could do. If you think about this problem, there's heat transfer in a composite material. There's evaporation of the water, transport of the water vapor through a porous material, and then the stress analysis that goes with that internal pressurization of the porous material. So pretty complex computational analysis. So this team was left doing their research and development via building prototypes and going through an expensive testing protocol to be able to develop those materials. So they came to Altisim. They brought us in as their multiphysics simulation experts, and we plugged into their internal simulation team, and we developed simulations that included all of the physics I listed. Once we had those simulations developed, we were able to then run through a whole series of parameters that they had already tested, come up with data that we could then develop confidence in the model. Once the model had been validated and we had confidence in it, we could then extend the simulations beyond their experimental data set and identify material parameters and operating conditions that would allow them to dry the material as rapidly as possible without causing it to explode. And so in doing that through the simulations, we identified a set of parameters, allowed them to reduce their drying time by a factor of 2. Now that was a substantial financial impact on the company. They were able to save $5 million a year, and they were able to do that with a $50,000 investment in a multiphysics simulation project. So moving on to our second case study. This case study was a manufacturing process for nanotubes where they were pumping a gas through a plasma reactor. Now, our customer had been very successful at demonstrating their capabilities at the lab scale, and they'd received a good amount of funding to move up, and their next step was to move to a small manufacturing scale. Now, this company, although they were well-funded, they had no internal simulation capabilities. And what they realized was because of the extremely nonlinear nature of their manufacturing process, they would need to use a tool like computational simulation to move from the lab scale to the small manufacturing scale. And so they brought us in as the simulation experts. We developed a simulation of the plasma process, of the flow of the material through the plasma, the chemical reactions that were going on within that plasma. And from that, we were then able to develop a set of operating parameters that would operate at the small manufacturing scale. So we showed them how they could scale from their lab scale to their small manufacturing scale. That project took about 3 months. So they moved up that learning curve within 3 months and were then able to start operating their small manufacturing facility. Now, one of the things I've noticed in doing these multiphysics projects over the last 20 years is that we have a general arc of how our projects go. And so I wanted to share that with you guys today. And that arc is that through our multiphysics simulation, we're able to develop a very robust and extensive data set. And we generally develop that data set around a set of known operating parameters. Now, once we have developed that robust data, the team, which includes our Altisim simulation experts and our client's engineering team, that team is then able to take that data, assimilate it, develop an understanding of what's happening that goes beyond what you could get just simply from doing experiments. With that understanding, then, the team is able to make design changes that optimize the design against a particular set of metrics. It's like, how are we going to make sure that this goes quickly? How are we going to make sure that we use the minimum amount of energy that we need to? So whatever the parameter is, we can design against that. With that, I'd like to turn the rest of the presentation back over to David Jones.
Thanks, Kyle. All right, so you heard about 2 great case studies, and Kyle mentioned we've done over 800 projects. From that, we've figured out how to be a computer simulation expert at Altisim, and one of the takeaways is the time saving. When you're a product designer, an engineer trying to get a product to market fast, Using computer simulation, we found can save up to 90% of the time to bring it to market over traditional prototyping. So that's significant. The other thing is the cost, saving 50% of the cost. Now you can do things repeatedly at a lower cost because you're doing it on the computer. And you can try different variables. You can try to force your product to fail on the computer, and it doesn't cost you that much. Now, we have a lot of expertise working across a lot of industries. Consumer goods, communication devices, electric vehicles, particularly batteries we get involved in, electronics, just general engineering, whether it's around automotive, aerospace, space travel, medical device, and sensor design. All of those are really important markets to us. And why have we become successful? Because we have a very good process, our S3 process, around studying, simulating, and then solving. And our technical expertise is beyond just the computer. It's also being part of your engineering team. We understand your language, and we become part of that. We know about heat transfer, electromagnetics, acoustics, vibrations, and structures. And so we encourage you to reach out to us. We're a consulting business. We'll come in and help you as you need it, right? And so we're Altasim Technologies. We appreciate your time today. And if you have any questions, just please let us know.